All right, so with D, you have sine 2 theta plus 60 degrees is equal to minus sine theta, right? Now, this equation here, there are two ways of carrying on, right? First, you need to know that this minus, it tells you that our reference angle is in the second quadrant or the fourth quadrant, okay? That minus there. So the best way of carrying on to the next step is to use your knowledge of reductions. I'm sure you are aware that if the angle is in the fourth quadrant and it's negative, okay, we have sine minus theta, isn't it? Right? So we can go back using this reduction here. Sine minus theta is equal to minus sine theta. Moving from the right hand side towards the what? The left hand side. So that will give you sine minus theta. Now what this means is your reference angle becomes minus theta. Okay? So if I want to carry on here, I'll end up having 2 theta plus 60 degrees is equal to minus theta plus k times 360, where k is an integer. Okay, please be aware that your reference angle is this one here. That's your reference angle. Right? It's in the fourth quadrant. It has got a sister or brother in the third quadrant. So here we simplify, we take the minus theta to the left, so we get 3 theta equal to minus 60 degrees plus k times 360, where k is an integer. And then you divide both sides by 3. You end up getting theta equal to minus 20 degrees plus k times 120 degrees, where k is an integer. Are you following there? So I have dealt with the fourth quadrant. Okay? This general solution, it caters for the fourth quadrant. Then I also need to cater for the third quadrant. Now, since I know this is my reference angle here, all I have to do is subtract minus theta from 180. Okay? I hope you know that sine has got two general solutions. I hope you remember that. So from here, so this is my first answer. Okay, that's the first answer there. The second answer, we rewrite the left hand side, 2 theta plus 60. This will be equal to 180 degrees minus the reference angle, which is minus what? Theta. Then you add k times 360, where k is an integer. This will give you 2 theta plus, okay, let me take, okay, before I simplify. So this will give me theta equal to 120 degrees plus k times 360, where k is an integer. Okay, so that's the second general solution. Okay, and then you will be done. Okay, that's all you're supposed to do. How many of you got the answers? Thank you. If you didn't get the correct answer, I hope you can see the corrections. So sometimes when you're doing trigonometric equations of this nature, you might have to use your knowledge of reduction of negative angles. No. You see this theta here? Take it to the left, you end up getting theta. Do you see that? So if you want to test it, if this general solution is correct, right? Let's say you put k equal to 0 here. Please be aware that I'm almost concluding the general solution now. When k is 0, means theta will be 120. So you can just test it, substitute 120 here, 120 there. Okay? If you put 120 here, you get 120 times 2, which is 240, plus 60, you get what? Sine 300. Now here you end up getting minus sine what? 120. I hope you know that sine 120 is the same as sine 60. So, and sine 300 will end up, so here you end up getting sine 300, and this will give you minus sine 120. Both of them can be reduced to, this one will become minus sine 60, and that one will become minus sine 60. So you get the same result, and you end up getting minus square root of 3 over 2 on both sides. So the answer is correct. So whenever you get a general solution, you can test if it is correct. Yes.
Since we said that we work with the fourth second quadrant, in the second quadrant, sine is negative.
I think I might need to explain to you what's happening because you are missing some things. If an angle is negative theta, then theta is acute.
Yes.
Which quadrant is that? Fourth. And if the fourth quadrant is sine positive or negative, in which other quadrant is sine negative? Right. So the reference angle there is a negative what? Theta, which is the same as 360 minus theta. That's in the fourth quadrant. So how do I get the one in the third quadrant? There is no need to convert that minus theta to 360 minus theta. In this case now, there is no need to do that. Okay? Because remember, a general solution, it can help you to even determine negative angles. So there is no rule. I mentioned, can you pay attention? Pay attention. I mentioned this, I think, probably the first day or so when I introduced trig equations and the general solution. There is no rule which says the reference angle must be positive. That's not correct. The reference angle can both be positive or what? Depending on the quadrants. So for this question here, because we have minus sine theta, it's a hint that we are dealing with a negative ratio. And the negative ratio will correspond to either third or fourth quadrant. Furthermore, the angle can be positive or what? Negative. So if you have got theta, then it has to be minus theta. That will give you a negative ratio in the fourth quadrant. So don't think about it in terms of first and second, because the ratio here is not positive. The ratio is what? Negative. And we know that sine 360 degrees minus theta is equivalent to sine minus theta. They are the same. Okay, so we can use the reference angle which is negative to get the one in the third quadrant, which will be a positive angle, right? It will be a positive angle because if you see here, it's 180 plus what? Theta. So this is the angle in the third quadrant. It's positive. But it doesn't mean theta is positive. No. Theta is what? Negative. You end up getting this plus here because of the fact that the minus and the minus, when you multiply them, you end up getting a positive. Okay, I hope I've tried my best. Okay, so that's it for